Hi, welcome to Algebra 2 Common Core. Today in Lesson 5 we're going to talk about geometric series, where we have a geometric sequence and we want to add the terms together. So in exercise number 1, I'm going to go through how this sum is derived, how the general form is derived. So this may seem a little bit complicated, but this is the only time that we're going to do this. It says, given the geometric series 2 plus 4 plus 8 plus 16 all the way to 2 to the 10th, find the sum. So if I want to find the sum, that means that I am finding the sum of the first 10 terms. So for the sum of the first 10 terms, I'm going to just show this sum again. 2 plus 4 plus 8 plus 16 all the way to the 10th term, which is 2 to the 10th power. Now, we're going to look at a different method in math of finding this sum. And again, this is the only time you're going to ever have to do this. In general, we're going to be using a formula for this, but I want to show you where this formula comes from. So what I'm going to do is take this whole sum, and I'm going to multiply it by 2 and then subtract it from that first line. So I'm subtracting 2 times the sum of the. So if I double every term, the first term of 2 becomes a 4, so I'm going to line it up under the other 4. 2 times 4 becomes 8, so I'm going to line it up right here under the 8. 2 times 8 becomes 16, so I'm going to put it right here. 2 times 16 would be 32. And I keep going until I get to the second to last term, which would be 2 to the 10th power. But then we'd have an additional term, which would be 2 times 2 to the 10th power, which would have been my last term from the above line doubled. Now I'm going to subtract that whole line. So when I subtract that whole line, I now have, on the left side, S10 minus 2S10. On the right side, you'll notice that when I subtract the top minus the bottom, the 2 stays in my total. The 4s cancel, the 8s cancel, the 16s cancel, the 32s would cancel, all the way to 2 to the 10th. They would be the last terms that would cancel. So the only thing left over would be this term over here, 2 times 2 to the 10th. Again, remember that I'm subtracting that bottom line, so it would be minus 2 times 2 to the 10th power. Now if I take a look at this carefully, on the left side I can factor out an S10, the sum of the first 10 terms. When I factor that out, I'm taking an S10 out of here, which would leave me with 1, and I'm factoring an S10 out of here, which would leave me with minus 2. On the right side, I'm going to factor out a 2, and when I do that, factoring a 2 out of this term, I'm left with 1. Factoring a 2 out of this term, I'm left with minus 2 to the 10th. Now what that allows me to do then is to solve for S10 by dividing both sides of the equation by 1 minus 2. So I will actually have 2 multiplied by 1 minus 2 to the 10th divided by 1 minus 2. And we're going to see in a minute how this forms the general formula that we're going to be using. Now if I substitute, or if I put this into my graphing calculator and find the answer here, I'm getting a final answer of 2046. So that's the answer for this sum. Notice that in this sum, the first term was equal to 2. My common ratio was equal to 2 because I multiplied each term by 2 to get the next term. And n was equal to 10 because there were 10 terms in the sequence. So how are we going to then generalize this for our formula? Let's look at the general formula. So the general formula is S sub n equals, there's 2 different ways that I can write this, so I'm going to start with the first way. A1 minus A1 times r to the nth divided by 1 minus r. This is not a formula that you're going to need to memorize. You just have to know how to use it because on your Regents exam it will be on our formula sheet. Now if I look carefully at this, in the numerator I see that I've got an A1 that's common to both of the terms in the numerator. So another way of writing this formula is to factor the A1 out of the numerator and write it in front of the factor 1 minus r to the n. You'll notice that that's actually what we did for the example above. The first term was 2, then I had 1 minus the common ratio of 2 raised to the nth power divided by 1 minus the common ratio. Again, remember A1 stands for the first term, R stands for the common ratio, N is the number of terms, and Sn is the sum of the first n terms. So we're going to spend some time tonight working on using this formula to sum the terms in a geometric series, just like we did on our previous lesson with an arithmetic series. So we have to first of all identify which kind of series we have so that we can use the appropriate formula. Let's try exercise number 2 together. Find the sum of -3 plus 9 plus -27 plus all the way to -177,147. So our first job is to look at this and say, okay, I've got the first 3 terms of my sequence. So if I've got the first 3 terms, I've got A1 is equal to -3, A2 is equal to 9, A3 is equal to -27, and hopefully you're seeing that this sequence is a geometric sequence where I keep multiplying by r. R is -3. Now what I'd like to do is count out how many I need to get to this term right here. So if I keep multiplying by -3, and you can just do this in your calculator, A4 turns out to be 81, A5 multiply by -3 again, so -243. Looks like we've got a ways to go, but this is definitely the easiest way to figure out which term I have and how many I'm adding together. If I multiply by -3 again, I get 729. Multiplying by -3 again, -2187. Take a minute and keep multiplying by -3 until you get that final term. I finally found it as the 11th term. So match up your numbers and see if you got the same thing. So in this sequence, I've got that A1 is equal to -3. The number of terms in the sequence that I want to add together would be 11 because it took me all the way to the 11th term to get that last one. And the common ratio is also -3. That's what I have to multiply by. Now, don't get the idea that the first term in the common ratio will always be the same. We're going to see a lot of examples where they are not the same. So for a geometric series, we're going to say Sn is equal to the first term A1 times 1 minus r to the n all over 1 minus r. So for us, we're going to say the sum of the first 11 terms is equal to the first term -3 multiplied by 1 minus the r value, -3. Notice that I'm putting that in parentheses because I then have to raise that whole thing to the 11th power and divide by 1 minus -3. So putting this into my graphing calculator, I'm going to probably do the numerator separate from the denominator. And when I do that, I'm really dividing by 1 minus -3, which is 4. So I'm getting as my final answer -132,861. Check your answer with mine and see if you got the same thing on your graphing calculator. So make sure you're doing this on your calculator. So for exercise number 3, we want to write the finite geometric series and then use the formula to find the sum. So in part A, we want to start with -12, end with -972, and have a common ratio of 3. So that tells me that this time A1 is equal to -12, A2 is equal to, multiply by 3, so negative 36. A3 multiply by 3, and that's giving me negative 108. A4, keep multiplying by 3, so that's giving me negative 324. And I finally get to A5, when I multiply by 3 again, that's giving me negative 972. So I want to add together all of those terms. So the sum, notice that I've got 5 terms there, is going to be equal to the first term, negative 12. I think I'm going to use the second formula this time. So actually it's the first one that we wrote down. Negative 12 minus negative 12, so A1 minus A1 times the ratio 3 raised to the nth power, which is 5, all over parentheses 1 minus 3. Now again, on your calculator, make sure you put this whole numerator in parentheses and the whole denominator in parentheses. When I did this, I got for my answer for this sum negative 1,452. So check that on your calculator as well. For part B, we want to start with the number 8,000. We want to decrease by 25%. So if we're decreasing by 25%, that tells me I've really got 1 minus 0.25. So my R value that I'm multiplying by is 0.75. Notice that my A1 is equal to 8,000. And I know that I've got 6 terms. So for this one, we're going to say, start with S6 is equal to A1, which is 8,000, minus 8,000 times the ratio 0.75 to the 6th power all over 1 minus 0.75. Parentheses around my numerator, parentheses around my denominator, and that answer for S6 turns out to be 26,304.6875. Now if I list down all of those terms, I know that my first term is 8,000. Multiply by 75%, so my next term would have been 6,000. Multiply by 75% again, 4,500, plus 3,375, plus, and I would keep going until I got 6 terms there, each time multiplying by 0.75. For exercise 4, it says, which of the following represents the sum of a geometric series with 8 terms, whose first term is 3 and whose common ratio is 4? So this is just a direct substitution into my geometric series formula. So S8 is equal to, I think this time I'll use the second formula, and there's no special reason about which formula I'm using. They're both identical work algebraically. So the first term is 3 multiplied by 1 minus the common ratio of 4 raised to the 8th power, because there's 8 terms, divided by 1 minus 4. Now please don't get tempted to say, oh, let's cancel off a 1 minus 4 with a 1 minus 4. We cannot do that algebraically. But if we enter this into our calculator, we get the answer 65,535, which is exactly choice number 4. Exercise number 5 is an application problem of this geometric series. Maria places $500 at the beginning of each year into an account that earns 5% interest compounded annually. So looking at that compounded annually, you'll recall from our last chapter that to get the base, we're going to have to say 1 plus the R value. So in this case, we've got 1 plus 0.05, or 1.05. Now, don't get confused on this problem because we're actually using a different definition of the letter R in this problem. We've got as the A1 her initial investment, $500. And then each year she's adding on another $500. But technically, the original $500 earned interest. So we're going to take a closer look at this problem when we look at this again tomorrow. So we're actually going to say that this one also earned an extra amount of interest. This one earned interest as well as the years keep progressing. So what we're going to do is figure out how much money she's going to have at the end of 10 years. But what ends up happening is she's gone to 11 different deposits because she entered money at the beginning of the first year and then she entered again at the end of 10 years. So what we want to do here is look at the following sequence. 500 plus, when I add on that 5% interest, it'll be 500 times 1.05, and then 500 times 1.05 to the second power, and then 500 times 1.05 to the third power, all the way to 500 times 1.05 to the 10th power. So really what I'm doing here is finding the sum of 11 terms, where we're going to call the first term 500. But then we're going to subtract 500 times 1.05, since we're finding the 11th term, this is going to be to the 11th, divided by 1 minus 1.05. So S11, when you put this in your calculator and you round it because it's money, gives me a total investment value of $7,103.39. Now, tomorrow we're going to take a better look at this application. So if this one is not quite clear to you, that's okay. I wanted you to see the beginning of the problem tonight, and I wanted you to think about the fact that each amount of money that she entered is going to get interest added on every single year. The only one that's actually not going to have interest added on is this last 11th term. So really what we're doing is summing these terms backwards, where this A1 really ends up being this term down here. And this A11 really ends up being this term back here. But it is the sum of 11 terms, so that's the formula that we're going to use. We'll talk a lot more about this and some other application problems tomorrow. We'll see you in class. Have a great night. Bye-bye.